Hi everyone, welcome to Brick and Block and welcome to the next episode. And I'm very, very excited to welcome my next guest, Annie Marston. How are you?
I'm very well, thank you. How are you?
Very well, thanks. Thank you for joining me today at lunchtime. Appreciate you making the time. I know you're very busy. But first, before we sort of dive into some really interesting conversations, sort of touch base very briefly on your career, because when we worked together, you were previously at HDR at the time, previously HPF, but rebranded, I think, specifically for when you were there. Now I don't know if it was relevant or not, but you moved on to Hydrock.
Yep, that's right.
Yep. And then now you're at ReSustain. So you've sort of moved, am I right in saying this, from consultancy to a slightly different position as Chief Product Officer?
That is correct. I've moved from engineering to tech, which is very exciting.
Yeah.
More about that, I'm sure.
But I don't think I've actually asked you this particular question because you've also got a PhD, and I don't think I've actually asked you what your PhD was in specifically.
So my PhD was in blocking air traffic control radar, blocking wind turbines from air traffic control radar.
Oh, wow.
So it's sort of side kind of renewable sustainability,
Yeah.
climate change, lots of modeling, lots of modeling about how wind moves and things like that. So academia was my first way into the building industry. And then I went, academia, it's not practical enough. I need actual change. I need to see
Actual
change happening. So headed into industry as a building physicist for probably about 10 to 15 years, all over the world. So that was fun. And then I said, this is not enough change. I'm not seeing enough change. I need to see more. So I was given the opportunity to co-found this tech company, which I'm hoping will make more significant, more practical change. I want to see things happen immediately. I'm just, I don't have any patience. I just.
Well, maybe you'll completely change this. So with ReSustain, have you got a software that you're trying to enable things to happen? How's it working?
So basically what we do is we've got a sort of BMS side, energy side, and then a software side. And the three of us will come together. And essentially what we do is we recommission the controls in a building seasonally, remotely. So you don't have to go on site through our hardware, and then set alerts on those energy points to see if something's changed or something's happened, so we can keep buildings operating at the optimal level. Because I think, as we all know in the construction industry, there are stages where things change dramatically. And one of those stages is handover. And what I was always very interested in was existing buildings. Because I believe, and maybe naively, I don't know, but I do believe that throughout design is done very well. And it's done by people who are passionate and interested and educated and, want to make the best building. And that's great. And then handover, everyone just says bye. And then there's sort of one facility manager that goes on site once a week and kind of says, everything okay?
Yeah.
And so I feel like we don't pay enough attention to that part of it. And then buildings slip out of control. And so the really good performing buildings have been designed really well, aren't performing in the way they should. So that's why I wanted to come back in and say, look, everyone's done such a good job up to this point. Let's just use software now and engineering, very importantly, to ensure that building, that lifetime of that building stays as best it can in the place the designers wanted it. And sometimes even better, hopefully.
Yeah, it's a really interesting point. So my previous guest, speaking to Oliver Morris at CBRE, and we were having a conversation about the relevance of EPC versus neighbors. And, that led to a very interesting conversation. But I think what we were sort of getting to, and I'll be interested in your view on this, is that we sort of got to the point where we thought EPC still has a role in the industry. It's it has created I think a baseline where people understand it, and I think that's important for, people like, say, myself, who I bought a flat, about a year ago. It's a baseline understanding of how that building flat performs.
Mhm.
But I think, um, when you head into, say, industry, perhaps isn't enough. And quite right, as you've said, when you hand over, there's a lot more nuance in there in terms of how your electrical system, how your mechanical system works, how the fabric of the building is actually performing compared to when it is existing. And I mean, do you think that's as that's an apt summary or position, or do you think actually there's more to it than that?
I think it's a bit of both. So I think, yeah, although I have lots of problems with EPCs, I actually think they are
Yeah.
quite a good thing. I think in terms of legislation, in terms of pushing things forward, you need something which is relatively simple, but
Yeah.
keeps everything at a baseline. I think people should question EPCs a bit more. I think, especially engineers, architects, so on, should have
Yeah.
a look a bit deeper into how they're calculated. But overall, I'm pro EPC, which might be a bit of a surprise,
Pro APC.
and legislation. There are some significant issues that need to be ironed out, but that's fine. But I think when you get into existing buildings, you should also report against the actual energy because you have that
Mm,
data. So you have utility bills, everyone has utility bills, and that is much more revealing. So even though your EPC might be saying a certain thing, which is fine, what's probably happened in the building is the controls have gone wrong. I'll bang on about this, but I am bang on about controls. The controls
yeah.
have gone wrong, and essentially, you're losing a ton of energy that your EPC says you should be saving. And that kind of goes back to this. The design is correct. Everything is correct. It's just the building slides and it's complex. There's interactions between fabric and mechanical. They are complex. It's not a sort of, as much as every engineer would love, a closed up box with no windows
Yeah.
and one zone. It's not that. There are people involved. There's comfort involved. There's different levels of experience of the space, which are really important.
Mhm.
And designers, architects, engineers will think about that. By the time you get to the existing building, it's not there. So I think the most revealing thing to show about a building is how much energy it is actually using.
Yeah.
I'd like to use EUI measure, energy use intensity measures, because I think then you cover a really good compare and not to judge, just to say, always question, why is my building using, 100% more energy than the one next door or my other building
Yeah.
over here? And then start that questioning process. And that's what's important is that questioning of where are we rather than I've got an EPC of a C, I'm going to spend a ton of money to put something in, get an A, and the energy usage in my buildings are going to change. So
So, I mean, I mean, you mentioned operation in use. So, for example, for argument's sake, when we were like working on Holbein Gardens together, how can you truly determine the use of a building? Do you have to take some stab at it in the sense that, for argument's sake, so, the tenant going in to Holbein Gardens is a financial hedge fund.
mhm.
So their hours are quite crazy in some sense, aren't they? Because they've got to be on the market, they've got to be working long hours. It's a hard sort of working profession for that, and the hours required for it. But you can't. I guess you. I mean, that's just one type of industry. So can you tailor it to that side of things, or do you have to take an average and then realize that afterwards, actually, well, you've got a company that's in there that is needing to use it for longer, so you are having to burn more energy, whatever.
So this is where I think tech and engineering and all of that comes into play because I think benchmarks are useful in
Hmm.
design, but when it comes to in use, I am a firm believer you can build an energy model which reflects the building exactly. And exactly, I mean, obviously, not exactly, but you can calibrate it.
Yeah.
There's methodology to calibrate it, so on. So you can say this model here represents my building. And then from that, you can take into account those working hours and so on. But what I think we tend to neglect or we tend to think about, I think what we think is that buildings work. automatically without help, and they just don't. So it's easy to sort of blame the occupier. Oh, they're working long hours. But the types of things that we find in existing buildings are the fans have been left on a 24/7 schedule. Now, even the hedge fund managers are,
Mm,
well, some of them sadly are sleeping there overnight, but most people are not in the building that long. So it's usually a mistake. Also, conditioning space is separate from providing ventilation or using plants. So it's all these kind of considerations. So my solution or, my opinion to a solution
yeah.
is you do calibrated detailed energy models for every building, and you let that inform the decisions that are made moving forward. And in our industry, we are terrible at sharing models. We're really good at sharing
Mm,
information,
yeah.
but we're not very good at sharing models. And I don't know why, because once you've got a model, let's not make someone else make that model. And then again and again, again, it's like data entry. Don't keep doing data entry once it's done. Let's leave it and move on. So I think there's something to be said that if you can, if you have those models, and we did have, well, we certainly had some models for Holbein, they
Yeah.
should just run with the projects. Let them go, let other people use them, share your expertise as you would with anything else you do, and help them,
Mm,
and let that go with the building. And that will provide much more insight to what's happening. And also you can test things in the model rather than on the occupant, which is always good. But it's also that thinking. And
yeah.
go back to this again. It's that thinking. When you have to draw something, you have to model something, and you have to use it, you have to think about how it's actually working. And that often sparks the idea of how to solve that problem. So,
One of the things that often came up when we were going from design to construction was the ability of the subcontractor team to pick up this design analysis that the design consultancy team have done. And it was a interesting experience on Holbein because we found that your team, you developed all of this information. There was a hell of a lot of analysis, and not necessarily the subcontracting sort of team of the industry is there just yet. And to be fair to them, they did get someone on board. They had to upskill. They worked with us to develop it because we asked them to do that. But do you think that as from an implementation perspective, and I want to touch on a separate question on this, that there's a lot more education we need to do from, so I guess a responsibility that we need to bring other people on board with the journey. And I wonder what your thought is to implement something. How is the construction side performing, in your opinion?
yeah. So I've always had this sort of sadness that there's the design and then construction and then operation, and it's almost a completely different set of people doing each of those.
Mhm.
And we need a way of communicating along those lines. And I know that BIM has been that's a trial to sort of try and make that happen, but I think there's more to it than that. I think there's definitely education that is required, just generally of everyone. I think I'm very pro education. I think the more we have, the more
Yeah.
we understand, the more we can deal with it. And I think just generally on the construction side of things, to include more specialists, which I know cost is always an issue, but to include
Yeah.
more specialists to be able to drag through some of the more complex design ideas into a more practical implementation, because I do fully understand that, you've designed a very complex solar thermal heat pump system, and there
Mm,
might be some practical implications that have not been addressed, and you need someone there to help guide that through, who understood why it was being done to begin with, and then what potentially you could switch out, change, or what the impact of that is. I think one of the problems with when design gets to construction is that sometimes things are taken out, um, which can be taken out, but should be replaced with something else, but are just
something
taken out.
else.
So just a little bit of thinking of, okay,
Mm,
that's too expensive, fine, but what if we did this idea instead of just slashing it and moving on. So I think there is, I think there's roles there for everyone. And I think it's just the way the industry is set up is just very segmented, and we need to start thinking of it as a full journey, a bit like
Mm.
whole life co-op. Actually, we need to start thinking of everything as the full journey and bringing people through, even if it's just a handover into construction or a handover from construction to operation. Just not the slashing of sides as much as there is.
Do you think that, usually we try and, I mean, architecturally, Barcasodas, we always try and get novated over when it's a D&B, because that's only great for us because we get to deliver the scheme. It's great for the client because they have some onus that, the architect has come on, and then we usually then create a client monitoring team who can stay on the client side. Do you think, inherently MEPH consultancies usually stop at tender, and then on occasions, probably sometimes will have a client monitoring role? Do you think then that from a project team setup actually maybe needs to enhance a bit more to allow for this element of newer? Because essentially with, certainly in the last few years with neighbours coming on board into the UK, it feels like there's a lot more nuance and detail and analysis that perhaps we need that additional expertise that perhaps we maybe didn't need before.
Yeah, I think very much so. I don't think it's by choice, actually. I think the MEP team would love to be novated over, but there's just a point where it's like, no, you're too expensive. We've got our own MEP team. They're going to do what they're going to do,
Yeah.
which is fine. But yeah, but I think there are often as well, up to stage 2 will be a different MEP team to 3 to 4, which is even in design, you get that break. But I think that's where the role of the sustainability team or the energy model can really take, because they can pull. My mission in life was to get the model done at design,
Yeah.
at stage 1, even conceptual design. There's slightly different models as you go through, but have that energy model moving all the way through to operation so that people can see what the different design decisions were and how they impacted the energy in the building. We're lucky. Well, we're not lucky because climate change isn't a lucky thing, but we're
Yeah.
lucky that this has become much more to the fore now. And people are more interested in energy in buildings. Whereas before, for MEP, it was just, make the building warm enough, cool enough, and make
Yeah.
sure that people can breathe. And that was really the limitations of what had to be done. So it didn't particularly matter if there was lots of energy usage or, um, but now there's no one specifically looking at the energy. Everyone's coming from their own sides looking at the energy, but there's no one there to tie all
Yeah.
the threads together and say, okay, so, if the architect decides to put a single glazed window in, what is the
Yeah.
impact then on the MEP systems? And let's
Mm.
figure out what that means in terms of energy and how we might mitigate that, or if the VE out triple glazing to double glazing, what's the implication on the MEP systems? What's the implication on the chillers and the boilers? Like, let's look at that decision, because you might then have to put in a second chiller, and is that a good thing or a
Mm.
bad thing? So I think that the role of the sort of modeler of the sustainability team, of the they can kind of start pulling those threads through and helping the design team navigate, you know, ideas that have impact on each other. And that's
And
nice.
yeah, it is. And I think certainly for us as a designer, not just architecturally, I think it affects a lot of things. It can become an informed decision. When we were working together, we looked at the embodied carbon. We looked at, what is the right structure to use. And we ended up, after exploring lots of options, a hybrid system. So we got steel and then we got CLT. And then obviously that then has an impact on the energy, right? In terms of, how does the CLT perform thermally? And then what does that mean do we then go for an SFS system, or we did do a bit of a hybrid system. So we ended up brick on the outside, uh, SFS internally. And then we had humongously thick walls, thickest I've ever done in my career so far. So, but then again, you're 100% right. We got another consultancy to help us with the U value calculations, because we were doing something quite bespoke with this and with the CLT that we had to, you had given us some parameters to work to. We then had to see if we could meet that, and we had to test it. lots and lots of coal bridges everywhere with existing buildings. Uh, so I certainly found it a bit of eye-opening experience because it gave us, I think, a lot of things to think about. But I think without that individual that you've just mentioned to sort of drive the conversation to say, okay, you can do, like we ended up dropping triple glazing because we actually felt from an embodied carbon perspective, it was too high. And then it was marginally better in our scenario. So we did drop down to double glazing. And obviously it saved us a lot of money as well, which is also great. Fantastic.
Okay.
But I think those are informed decisions because I think, probably 5 years ago, me in a naive position, I would have gone, why aren't we doing triple glazing? Because it's the best decision, right? But I've been finding recently that as soon as you throw in energy modeling and then you look at the percentage of performance increase, it's never actually a straight answer, is it?
No, but that's the whole thing, isn't it? And that's what's so interesting. I love puzzle
Yeah.
solving, hence my job. But no, that's exactly it. It is about the balance, and it's about the theory of how you're going to heat and cool the building to start with, and the balance of that. So if you're going for passive design, there's various things that you need to work out. You have to keep or you can't have, and then if you're going for active design, likewise. So it is about that. It's about understanding what the energy strategy is and then making those informed decisions. That's all. That's all we're here. Advice and
Mm.
informed decisions. But that's it. I like it when I'm wrong. If I think something should happen and I model it and I'm wrong, that makes me happy because I know that I've made, I have learned myself that this is what happens. And okay, that, it's increased the cooling. Therefore, this is, more energy and so on. So I think I think there's a real place, especially during VE or during, considerations of design like that. If you can put it through the model and you see it has a marginal energy performance, then, save the money. No one's trying to spend a lot of money on building
No, no.
it. Yeah. So I think that it's a really positive person to have involved. And I just think we'll make the building better in the long run.
Because I've certainly found that probably in the last, say 10 years ago, when you had a sustainability consultant sort of coming through, it probably was sort of happened a bit late into the stages.
Mm.
I feel that with the sustainability consultancy team has grown now, and you've now got a BREEAM person, you've got a WELL person, you've got someone who looks at smart strategy, you've got energy modeling. But I think hopefully what would be nice is that the energy modeling, the thermal analysis comes further. So we are getting that individual from day one as part of this wider team to help us understand things a bit better. And one thing I was interested to hear your thoughts on was we talked about implementation earlier on. Do you think that there's a big percentage difference between, or maybe the point is tolerance of design and the construction element? Because do you think that, obviously new build, you've got much smaller tolerances. Holbein Gardens was a existing building. We had a few surprises when we built it, but when it specifically comes to retrofit, do you think there's a bigger tolerance that you have to build into the model to when you
I think,
think it comes up to in the end?
I think there is. I think, especially with retrofit, I think what we often don't do is understand the building to begin with.
Hmm.
So what was the building built for? What was its heating and cooling strategy? What was its energy strategy? Let's start there and then look at if we change it in certain ways, does that mean we then essentially have a new build because you're not using anything
Yep.
strategy wise that was there before, just the beautiful shell? And I'm not against the beautiful shell. I love a beautiful shell, but is it aesthetically we're retrofitting this? So
Yep.
sorry, we're retrofitting this just to keep the aesthetics. Therefore, it's basically a new build inside
Yep.
the current walls, or are we actually going to use, especially with Victorian buildings, they had really good energy strategies. So are we then going to incorporate that now into our retrofit? And in which case, it's kind of like you really have to understand from the beginning, and then there will be tolerances because you're always going to find some strangeness always. But um, but if you're there alongside it, you can start looking at that and understanding how that is, how that's
Yeah.
working, why you've got those sort of differences from what you were expecting beforehand. But I think the key thing with retrofit is really fully understanding right at the beginning how the building was supposed to work, and then taking that understanding and saying, which way are we going to go? And then that's where, again, all the modeling and the design can come together, and it's holding that thought from beginning to end. So you always have the aesthetic, you always have the MEP, as it were,
Yep.
but you don't necessarily have what was the original energy plan for
Yeah.
this building. And it's where things can really start going wrong. Because if you designed in a natural ventilation strategy for something, that's very, very specific, and your whole MEP system has to work with that. But if you're changing things down here, but you're keeping the natural ventilation strategy, the whole building's gonna just go wrong. Much like, if you suddenly took a chiller out, or well, a really good example is if you suddenly start pulling boilers out buildings and just directly replacing with heat pumps,
Mhm.
it's not quite, it's going to sort of work, but it's not going to work well because
Yeah.
there's a different design strategy there.
I mean, on that point, actually, a lot of buildings are trying to go all electric. And you mentioned
Yeah.
taking out certain bits of equipment. I was having an interesting conversation about electric cars and whether if everyone suddenly went electric, there's not enough power in the grid. In the same way, if all of our buildings went electric, can we actually sustain that? No.
I don't think so at the moment. But it is, again, it's the wider picture, right? It is um, reduce the energy first. I mean, it's what we've always taught, reduce, reuse, recycle.
Yeah.
And I think a lot of the time we're going for the easy solution, or the trendy solution at the time. And the trendy solution right now is to
Yeah.
replace with heat pumps. There's lots of good reasons for that. But if your building isn't built to maintain lower temperatures, if your building isn't working effectively, then those heat pumps are going to require more energy from the grid. So, I mean, we're talking, I would say, existing buildings right now use between 20 to 60% more energy than they need to. So, if you can reduce every building by 30% of its energy usage, well, then that's a lot less demand on the grid if you start putting heat pumps in. So, it's never quite as it's never the simple answer for me.
No, but
It is
that's
about how do we electrify, and,
yeah.
yeah, um,
But it's efficiencies though, isn't it? I mean, you mentioned, one of the things that you look at your company is the BMS system. And certainly my eye-opening element is, oh, it's BMS system. It's just something that sits in a corner, does some, turns on and off, turns off. But, we looked at trying to be a little bit more intelligent. And there's a big wave happening right now, certainly in the last couple of years, about smart buildings right now. Does that actually have legs, or is that a bit of a farce? Because I feel that it's a bit of both at the moment. Like there's a lot of badges going on. Like, do you remember with like certifications, like, oh, we've got this, we've got that. Like, is it a farce in the sense that people are just saying, oh, we've got a smart building, we've got great connectivity, here's a map that does this, which is fine to a level, I think. But you're 100% right. I think when you go back to a facilities management perspective, um, you know, do they have the information they know to run this building? Is the tap suddenly not working? Can they get an alert on their phone to know, yep, that's not working? Windows not closed on third floor, bay number 52, whatever it might be. Is that the stuff that we should be focusing more on in terms of sensors within products? Or is it more the nice to haves?
I think I think at the moment there's a rush for data. And I think
Yeah.
what people are forgetting is that you have to do something with that data to make it
Yeah.
useful. So I think right now the rush is, let's just get data. And so
Mm.
smart buildings are all about how many sensors can we put in, how much data can we collect from this building, which is lovely. But until you actually do something with that data, like you were saying, until you use it to send an alert or use it to do something, um, it is actually pretty useless.
Yeah.
And I think the other thing is that the tech industry potentially doesn't quite understand construction, engineering, um, architecture industry. And I
Yeah.
think that there's a lot of the smart building craze, a lot of the data, uh, people are using AI, machine learning on it. But what they are forgetting is that the designers, that they already know those things, that the computers don't need to learn them. We have learned them before, and you can skip a lot of steps by saying, here's the data. This is how an engineer would analyze it. Now, on top of that, learn from it, but don't learn how an engineer would do it, because that's going to take you ages unless someone's sitting in
Yeah.
the corner over that's very able to do that. So I mean, I wonder if it's similar from an architecture design point of view, where AI is designing buildings like from scratch. You're like, you don't need to go from scratch.
Yeah.
Here's the sort of basic. Now, if you want to do a little bit of, you know, playing around with that, that's great. But we don't, I don't need to give you like a rectangle and we know
Yeah.
the
No,
basics.
it's
We don't need windows and
exactly.
doors. Yeah, so I
No,
think
but
there's
I
a
mean,
bit of
look,
that.
it's using. I mean, technology can be used in the right way. I was saying my previous podcast with Ed Crump that AI is getting there, but it's not really what we want it to be. Like I likened it, and my best analogy is I want to hit a U value of 0.1 for argument's sake. What could that be? If I go for a timber construction and my wall's going to be 300 mil thick or 400 mil thick, if I suddenly decide not to use mineral wool and I go for sheep's wool, which is great, super cool and interesting, am I going to have a 500 mil thick wall? And I think that's where exactly what you said, I don't need AI to tell me to make a rectangle. I need AI to tell me the variations of a scenario. And I think that can then inform all of us in the way that we design. So I'm very excited to see what that could happen. It's certainly not there just yet. But yeah, I mean, on the point of technology, and you mentioned, don't just collect data, do something with it, and analyze it. Do you think there's some pitfalls that people need to be aware of that they necessarily don't, just like you said about, tech companies just doing stuff, but actually we as designers, don't just take it, but is there a way that they should be thinking about using that information properly?
Yeah, I think some of the pitfalls are that uh, you're expected to understand the data,
Mm,
which is interesting. Um,
I don't.
yeah, which I think is yeah, and I also think that there's a kind of false reliance on it. I think one of the things that I only really explained this through the BMS, but people have people say we don't need to optimize the building because we have a BMS that does it for us. And it's this kind of misunderstanding of the what the role of that specific thing is. And I think that's the same with any tech. I mean, let's say BMS was the first tech that went into a building, right? It was the first
Mhm.
time we were controlling centrally. Um, but there's that kind of misunderstanding of what that tech is doing. So you could say, I've got, this amazing lighting system. It's all controlled by occupancy, la, 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 la. But what you might not understand is that it it doesn't actually control the lighting system. It's expecting you to do that from a, panel. So I think there's a bit
Mm,
of a maybe we think tech is better than it is. I think that's our pitfall because we've got so used to everything being, you know, great and convenient and does what we need
yeah.
it to do. Um, there's maybe a misunderstanding that, especially in the construction industry, it's still very basic. It's still very, crude. Um, we haven't been paid attention to by the big boys in Silicon Valley or anything. So we don't have that level of uh, intelligence yet within our industry, within the tech, which is an exciting place to be because we can start putting it in. But um, it's very different. Your smartphone and whatever thing is going in your building, your smartphone is considerably smarter than whatever tech you're putting in your building. But why would we
Yeah.
see them as different? Yeah, yeah. I think
But
that's the pitch.
it's also accessibility, isn't it? I mean, it was a tongue in cheek answer for me that, I mean, yes, as an architect, I will understand certain amounts of data, but I am not an expert. And I was in a room recently with a client, and we had a tenant. It was a client, tenant, and MEP sort of conversation about how to manage a building, sort of stage 6, stage 7 handover, operational sort of conversation. And we had pulled information from a BMS system, and the tenant, they had their facilities team. And they said exactly what you said. They were like, I don't really get what this is trying to show me. Like, could we manipulate it into something? So it feels like you're right. There's certainly something happening right now where there is a rush to put stuff in. If you think about well certification, for example, there's a lot of like sensors that you can put in to know the air quality, or, carbon monoxide, all these bits and pieces. And that's great, but then it's trying to understand whether there's a proper use for it. And then you can take that data and you go, okay, I'm going to change this. I mean, I guess one of the things that probably we as a company would love to know is fabric elements, obviously, because that's our forte. We need to control that to help the system, the building system, work efficiently. What's the most optimum way of designing it? Bargazettas do a lot of retrofit. That's something that has become a strength for us. But in the 10 years that I've been here at this company, I can definitely say that every single building is not the same. And you're 100% right. You said this earlier on, that you can't, it's not like a new build, is it? You can design it, you can think about it, but until you actually see what the elements are, until you start peeling back the inner leaves, it could completely change. But it feels like I definitely could chat to you for another couple of hours very easily, but I'm going to try and wind up because I appreciate I've got to let you go. But in terms of, if money was no object for you, and you had all of the investment that you needed,
Great.
what do you think you could do to tackle climate change? What would be your one thing, perhaps?
I think I'm going to cheat here because I think there are two things.
Okay,
So
I'll let you off.
my first thing is education and diversity. So I think that one of the problems that we all have is that we're all like pushed into deadlines, like fast
Mm,
thinking. There's only so much money here. Everyone's just like, let's get it done. So my dream would be, if I had all the money in the world, it would be that we spend it on, first of all, education for anyone who wants to be educated within the climate change. And I'm going to specifically say buildings because that's where we are. We like the buildings.
yeah, yeah,
um, however they wanted. And also then for in a design project that uh, they are paid separately from the client. If you see what I mean? So there's no financial burden. And I think without the financial burden, you can come up with a lot of very interesting ideas, and then getting more diverse thought into the industry is fascinating. So my first answer would be to plow money into education and taking the financial pressure off design decisions,
yeah.
which is everyone's dream, really.
That
But
would be the dream.
my second, which is a much more practical kind of down the line solution, is I am an engineer after all, practical, and I need practical end,
Yeah,
um, is to optimize the controls in a building. I think that existing buildings, we expect too much from them. We think that they do too much. And if I had all the money in the world, I would continue to do what I was doing now and make sure that every building had an optimization system in it that was clever enough to ensure that it worked as the designers had specified. Even that, and then better maybe, but that it works as the designer specified, and someone or some tech thing is always looking at it and correcting it. And then it would be my little corner of the world. And someone else with unlimited resources. those are the two things. I think education,
Yeah,
questioning how we're working is really important, and get those buildings controlled properly.
I,
And we're
I
halfway there.
100%, I 100% agree because I mean, certainly in the last 5 years, my education, my learning, we all continue to learn, has definitely grown through recent projects where I, as an architect, I think it's probably fair to say architects are a bit naive at times, and we've all, I think, have become to realize that we need to know a little bit more about. It's not just, does it hit a U value? It's the consequences of that design and being informed, as we have talked about in this episode. And, you know, the optimization thing, I think, is such a key thing. I've just become more aware of it in recent conversations about how facilities teams manage the building. And sometimes it does feel that perhaps we have overcomplicated it in some areas. And it also feels that we're not getting the right information out of it. So it's
Mm.
information that we can definitely use. We've said this before, and I think that simplification, and as you've said, like maybe we're thinking that it could do something, but perhaps it doesn't. So it's very interesting. But yeah, it seems to be exciting. I'm going to cheat and ask you one more question before I let you go. But sort of looking ahead 5 to 10 years,
Yeah.
do you think that the technology side will benefit us with a bit of machine learning, and our mechanical equipment, our MEPH equipment will become a little bit more intelligent to do that, or not?
Yes, I actually think we're on the precipice of quite a large change in the construction industry, because people are looking. People are looking because of climate change and fuel prices, and before we've been able to brush it under the carpet, but now we
Yeah,
can't. And our best tools right now are the people in the industry and the tech that can take out the boring data entry, not necessarily the thinking, but we're all given mundane jobs to do every day. If we can get the tech to do that, and then all we have to do is think of the solutions on top of it, and then it will start learning, various things as well. But no, I think we are on a precipice, and it's going to be quite interesting to see how it works because we're an old-fashioned industry.
yeah.
So, yeah,
We certainly are.
it's gonna be a bit of a
But,
clash, I think, a bit of a fight, but, you always wins, really.
well, it's definitely changing. I've seen a change. So yeah, if I had a glass, I'd be like, let's toast a change, but let's see if that can go. But thank you so much, Annie. I really enjoyed talking to you today. I've learnt a lot, learned so much. And for those listening today or watching, thank you very much. Like, share and subscribe, and I'll see you in the next episode. So thank you again, Annie.
Thank you.